Hello everyone, how are you all? I hope you're doing well. So our next question is evaluate integral x square cos x dx. So we'll consider let I equals to integral x square cos x dx. So here this x square is taken as f of x and this as g of x. So this is nothing but integration by parts method. So we'll find the value of f dash of x, right? F dash of x will be equal to the derivative of the x square is 2x and g of x value is cos x. So integral g of x dx is equals to integral cos x dx, which is equals to sin x. So now writing the formula, so integral f of x g of x dx is equals to f of x integral g of x dx minus integral f dash of x into integral g of x dx whole dx, right? Substituting the values, so it will be I is equals to, so f of x value is x square into integral g of x value is sin x minus integral f dash of x value is 2x into integral g of x value is sin x dx, right? Now we'll write this constant 2 outside, so it is I is equals to x square into sin x minus 2 integral x into sin x dx. Again this is in the formula of by parts only, integral f of x and g of x. Okay, so here our f of x is x, so f dash of x value will be 1, right? For this term only we need to solve. And g of x value is sin x, integral g of x dx is equals to integral sin x dx, which is equals to minus cos x. So this is our formula. You need to remember this in order to solve any question which has two functions, right? In the by parts integration method. So now this is equals to x square into sin x minus 2 f of x value, which is equals to x. Okay, we are solving this. So it is x into the integral g of x value is minus cos x minus integral f dash of x is 1 into, again it is minus cos x dx, right? So this is equals to I is equals to x square sin x minus 2. This will can be written as minus x cos x, and this is minus into minus becomes plus integral cos x dx. So this is equals to x square sin x minus 2 minus x cos x, and cos x integral is sin x. Now multiplying minus 2 inside, so it will be I is equals to x square sin x plus, right, 2x cos x, and this will become negative 2 sin x plus c is our answer. 13th question is evaluate integral tan inverse into root 1 minus x by 1 plus x dx. Okay, so we have to put in this case x is equals to cos theta. So the value of theta becomes, if cos comes here, so it is cos inverse of x, right? And if we differentiate this, we'll get dx is equals to cos x derivative is minus sine, right? So it is minus sine theta d theta. We'll solve this term first. So it is 1 minus x by 1 plus x. So this can be written as 1 minus cos theta by 1 plus cos theta. And the formula of 1 minus cos theta is 2 sine square theta by 2, and 1 plus cos theta is 2 cos square theta by 2. So the 2 gets cancelled out. Sine by cos is tan, so it is tan square theta by 2. So now we'll write our question integral tan inverse root of 1 minus x by 1 plus x dx, which is equals to integral tan inverse of root, the value of this, right, we got, which is tan square theta. So it is root tan square theta by 2 into the dx value, which is minus sine theta d theta. So it is minus sine theta d theta. Here the square and root for this gets cancelled, so it will be integral tan inverse into tan theta by 2 minus sine theta d theta. Okay, so there is this thing you need to remember: tan inverse into tan theta is equals to theta. Okay, this is the rule. So now here the theta is theta by 2. So this is integral theta by 2 minus sine theta d theta. So we can write negative and 2 outside as a constant. So it is minus 1 by 2 integral theta into sine theta d theta. So this again we have to use the integration by parts method. So our f of x is theta here. This is f of x and this term is g of x. Okay, so here f dash of x will become like f dash of theta, it is in place of x, so it is 1, and integral g of x value is here sine theta. So integral g of x dx, we can write theta also. I'm writing x because everywhere we have solved in that way. You can write theta here. Okay, so here it is integral of sine theta is minus cos theta. I'm not writing the formula, I'm substituting it directly. Okay, so this is equals to minus 1 by 2. The f of x value is theta into integral g of x dx value is minus cos theta minus integral f dash of x value is 1 into integral g of x value is minus cos theta d theta. So this is equals to minus 1 by 2, and this minus we can write in front, so it is minus theta cos theta, and this minus into minus become plus integral cos theta d theta, and this all remains same. Integral of cos theta is sine theta, so it is plus sine theta. Now we can multiply this negative inside, only the negative, so it will become 1 by 2, and this becomes positive, so it is theta cos theta, and plus into minus is minus sine theta. As we have considered the value of x is equals to cos theta, and so from here we'll get the theta value as cos inverse x, and we know that the sine theta is equal to root 1 minus cos square theta. So here we can write it as root 1 minus cos square is nothing but the value of x is cos, so we can write it as x square. Sine theta can be written as root 1 minus x square. So here it is 1 by 2 into the value of theta, which is cos inverse x. So it is cos inverse x into the cos theta value is equal to x. So it is into x minus the sine theta value is root 1 minus x square plus c is our answer. Our 14th question is evaluate integral x into root of 1 plus x minus x square dx. So this is in the form of our working rule is px plus q is equals to a into d by dx of the quadratic function ax square plus bx plus c plus p. So this is only our linear function. So x is equals to a into d by dx of the equation, which is 1 plus x minus x square plus b. So this can be written as x equals to a into The constant derivative is 0, so I'm not writing. X derivative is 1 and x square derivative is 2x plus b. Now compare x coefficient and constant terms on both sides. We'll get x is 1 here, and for this it is for the a term, so it is minus 2a. So we'll get the value of a is equals to minus 1 by 2. And the constant term, here there is no constant, so it is 0 that side, and here it is a plus b. So we can write a plus b equals to 0. So the value of a is minus 1 by 2 plus b equals to 0. So from here b is equals to plus 1 by 2. Now substitute these values in this equation only, take it as 1. So substitute a, b in 1, we'll get x is equals to minus 1 by 2 into 1 minus 2x plus 1 by 2. Now multiply by our root term, which is 1 plus x minus x square, and integrate on both sides. So we'll get integral x into root of 1 plus x minus x square dx is equals to minus 1 by 2 integral root 1 plus x minus x square into 1 minus 2x dx plus 1 by 2 integral root 1 plus x minus x square dx. Now for this root term we can write it as power 1 by 2. Okay, so this is equals to, writing only this side term. Okay, so it is minus 1 by 2 integral 1 plus x minus x square whole power 1 by 2 into 1 minus 2x dx plus 1 by 2 integral, this remains the same, dx. Now this is in the form of the formula integral f of x power n into f dash of x dx is equals to f of x power n plus 1 by n plus 1. This formula you need to remember. And for this term you need to add and subtract the x coefficient by 2 square, which is the coefficient of x here is 1, so it is 1 by 2 square. So this is equals to minus 1 by 2. So f of x is our this term, right? So it is 1 plus x minus x square. N value is 1 by 2 plus 1, right? By 1 by 2 plus 1 plus 1 by 2 integral root of 1 plus x minus x square. So we should add 1 by 2 whole square and subtract 1 by 2 whole square. So this, if we add, it is 3 by 2. So it's get reciprocal, so it will become 2 by 3 into 1 plus x minus x square power 3 by 2 plus 1 by 2 integral. Here we'll take this three terms together. Okay, we'll take minus common in the three terms, so it is 1 plus, I write this term as 1 by 4 and taking negative common, so it will be x square becomes positive and this also term becomes positive and this x becomes negative, right, dx. So now this is in the formula form, right? A square plus b square minus 2a, and here this 2 gets cancelled out. So we will left out with minus 1 by 3, 1 plus x minus x square whole power 3 by 2 plus 1 by 2 integral. Taking the LCM, so it is 4 plus 1, which is 5 by 4 minus, and this is a minus b whole square, so it is x minus 1 by 2 whole square dx. this equal to 1 by 3 minus 1 by 3 into 1 plus x minus x square whole power 3 by 2 plus 1 by 2 integral root of, this can be written as, the 4 can be written as 2 square, and it is root 5 by 2 whole square minus x minus 1 by 2 whole square dx. So this term is in the formula form, which is integral root of a square minus x square dx, which is equals to x by 2 root of a square minus x square plus a square by 2 sine inverse x by a plus c is the formula for this term. So we can write it as is equals to minus 1 by 3 into 1 plus x minus x square whole power 3 by 2 plus 1 by 2 into x by 2. So our x value is this. So this can be written as x minus 1 by 2 by 2 into the root of, means our question only it is root 5 by 2 whole square minus x minus 1 by 2 square plus a square. So the value of a is root 5 by 2. So it is root 5 by 2 square by 2 into sine inverse x value is x minus 1 by 2 by a value is root 5 by 2 plus c, right? So this is equals to minus 1 by 3 into 1 plus x minus x square whole power 3 by 2 plus 1 by 2. Now taking the LCM, so it is 2x minus 1, and this multiplies, so it is 2x minus 1 by 4 into root of this remains as it is root 5 by 2 whole square minus x minus 1 by 2 square plus this square and root for 5 gets cancelled, and for 2 it will be there, so it is 2 square will be 4, 4 into 2 is 8, so it is 5 by 8 sine inverse. Now here taking the LCM, so it is 2x minus 1 by 2 will be there, that 2 and the denominator 2 gets cancelled, so will be remaining with root 5 in the denominator plus c. And now we'll multiply this 2 inside, so it is minus 1 by 3 into 1 plus x minus x square whole power 3 by 2 plus 2x minus 1 by 8. And when we multiply this, so this thing, if we solve, we'll get the same what is in the question term. Okay, so it is 1 plus x minus x square, okay, plus 5 by 2 into 8 is 16 sine inverse 2x minus 1 by root 5 plus c is our final answer. Thanks for watching. Please like, share and subscribe.